Hello, PLP geometry. Welcome to the fifth video of Unit 4. So this is Unit 4. And we are still covering similarity in right triangles. This is actually the first video. Similarity in right triangles is going to be focused on right triangles. So similarity in right triangles. So this is video number 5, and we are talking about a famous theorem called the Pythagorean theorem. The Pythagorean theorem. All right, so let's talk about this famous theorem for right triangles. So I think you've heard this before. I know that in middle school you use the Pythagorean theorem to find distance. So again, I think you know the Pythagorean theorem. So the Pythagorean theorem, Again, spelling's not important. Pythagorean theorem, that's an O right there. So the Pythagorean theorem says the following. It says in a right triangle, the sum of the squares of the legs equals the square of the of the hypotenuse. Uh-oh. Man, it's gonna be lots of erase. The sum of the squares of the legs is equal or equals the square of the hypotenuse. That's good enough. Hypotenuse. Okay, so if I have a right triangle, and we talked about this back in Unit 2, right? And there's the right angles. Well, you have 3 sides. You have 2 legs. Those legs make the right angle. So they're the 2 sides that are perpendicular here and here. And then you have a side, the longest one, opposite the right angle. We call this the hypotenuse. So when we use the Pythagorean theorem is this formula: a squared plus b squared equals c squared. Now, when we use this formula, c is the hypotenuse. It's the longest side. So c must be the hypotenuse. And again, that's going to be the longest side. So it's always across from the right angle. So this hypotenuse will be our c. And then a and b, the legs don't matter. So I let this bottom one be a and this vertical one be b. Doesn't matter. But this is Pythagorean theorem. This is what you use to solve for a missing side in a right triangle. So you'll have to take some triangles. They'll give you 2 sides. Plug it in Pythagorean theorem and solve. Now we're going to do 2 word problems. Again, we'll set up triangles and use the Pythagorean theorem just like if it was a non-word problem. But I figure the word problems are a little bit more difficult, so we'll stick with those. Okay, so our first word problem here. So our first example. Okay, so this is a driving problem. So it says we're going to drive west 8 miles. Turn and drive south 11 miles. So there's our directions. We're going to drive west 8 miles, turn and drive south 11 miles. And it says, what is your straight line distance? Your straight line distance from the starting point. From starting point. So we're going to drive west 8 miles, turn and drive south 11 miles. And the question is, what is your straight line distance from the starting point? Okay, so let's refresh ourselves real fast on our directions, right? So this is a compass I'm going to draw right here. So let's remind ourselves that north is up, south is down, west is to the left, and east is to the right. So I would suggest you start sort of in the middle right? Don't kind of pigeonhole yourself. So this is where I'm starting from. So this is my S for starting point. Okay, I'm going to drive 8 miles west. I'm going to go this way. Let's call that 8 miles. Once I get there, I turn, and now I'm going to drive south 11 miles. So I'll go down south 11 miles, so a little bit further than 8. Good. And now the question is, what would be the straight line distance from the starting point? So what would be this? Right there. That's the question. Okay. So where the directions meet, where west and south meet, this is going to be the right angle in our problem. Let me change colors. I'll change to red. That'll be our right angle. So this is a right triangle. And if we're given 2 of the 3 sides, to find the third side, we'll use our famous Pythagorean theorem, a squared plus b squared equals c squared. Okay, so in this picture, the longest side, the hypotenuse, is our unknown side, c. So these two don't matter. I'll let 8 be a and 11 be b. So I'll type in, or I'll plug in 8 squared plus 11 squared equals c squared. Okay, so I'm going to square 64, or square 80, sorry, I'm going to square 8 to get 64, square 11 to get 121. I'll add those together to get 175, and that is what c squared equals. Sorry, 185. 185. And now we need to get rid of this squared. And in order to get rid of that squared, you don't divide by 2, which is the big misconception. You are going to take the square root of both sides. And now we're going to show you how to do this in Desmos. So you will get c out by itself. We're going to go take the square root of 185. This problem is going to say round to the nearest tenth. So we'll talk about that as well. So let me pause it real fast, and I'll get you to Desmos. Okay, so to get the square root, again, it's in the keyboard down here. So if you press the keyboard, the square root button's right there. So we're going to take the square root of 185. And what we get is we get 13.60. So 13, so C is going to equal 13.60. So we're going to round to the nearest tenth. That means we look at the 0 and we ask ourselves, does the 0 round the 6 up or keep it a 6? Well, because it's less than 5, that 0 does not change the 6. So your answer is 13.6 miles. All right, perfect. Okay, let's do one more word problem back here in our slides. Okay, so example number 2 here. The thickness of this pen always changes on me. Example 2. Okay, so it says we are going to place a 24-foot ladder against the top of a 20-foot building. And the question is, how far is the base of the ladder from the bottom of the building? So we're going to replace a 24-foot ladder against the top of a 20-foot building. And the question is, how far is the base of the ladder from the bottom of the building? Okay, so let's draw this fun picture here. So here is the ground, right? Here is my building. My building is 20 feet tall. I'm going to take my ladder, I'm going to lean it against the top of the building. So here's my ladder. I like to put rungs like this. And my ladder is 24 feet long. And the question is, how far is the base of the ladder from the bottom of the building? Well, that'd be this horizontal side at the bottom. We'll call that question mark. Okay, now where the building meets the ground, we assume this to be a right angle, and this is where your right angle comes into play. And now we have a right triangle. We have two of the three sides of the right triangle. We need to find the third side using Pythagorean theorem. A squared plus b squared equals c squared. Okay, in this picture, the longest side is going to be the 24. That's our hypotenuse. The other two don't matter. I'll let the question mark be A and the 20 BB. Okay, so A squared stays A squared, plus B squared is 20 squared, and C squared is 24 squared. Okay, so now I have A squared plus we have 400 equals 576. And now notice that the numbers are on opposite sides of the equal sign. Remember, you have to draw your line down the equal sign, right? To get the A squared by itself, I need to move the 400 over by subtracting it on both sides. So we're going to subtract 400 on both sides to get A squared equals 176. And now again, we need to get rid of this squared. To get rid of that squared, we do not divide by 2. We take what's called the square root. When you take the square root of 176, again, we're going to round to the nearest tenth. So we get 13.26. So again, that's the nearest tenth. We look at that 6. That 6 is bigger than 5. So because that 6 is bigger than 5, it will make the 2 become a 3. And your answer is 13.3 feet. And that is how far the base of the ladder should be from the bottom of the building. All right, thanks for watching. Good luck on your Pythagorean theorem practice.